Hi, and welcome to my shop. Thanks for joining me here. It's November 27th. Holy smokes, I can't believe it. And I'm starting work on this radio, which I'm going to call for now the mystery radio, because I don't know the make or model. So I'll find that out in a day or two, I'm sure. No problem. We can still start working on this. As far as I know, this is an operating radio. And what I've been asked to do is just go through it, make sure it's going to operate for many years to come, and that its performance is good. That's my objective. So right away, if you haven't noticed it, I certainly noticed it. So if I can get it on. It's very hard to get on camera, but there's a crack in the through a tear through the paper of the cone right there. And it looks like a previous repair done over here now that I'm looking at it. Looks like a small fracture or tear there. So, but other than that, not too bad. Looks like this looks like a repair of some sort here. So okay, step number one. Speaker. Okay, let's see. Well, okay, string in place. You can see the string there, in fact. Dial moving. I'm pretty sure this is just an AM receiver. No transformer in it. Although you might have spotted this guy sitting here. This was, which is the output transformer for the speaker. This is fairly large. Looks like it should be almost a power transformer, but I'm pretty sure that's a choke. As far as I can see, there's only two wires coming to it, so I'm pretty sure this is a power supply choke. And then we can guess that these there's 5 tubes in here. 1, 2, 3, 4, 5, 6 tubes in here. It's a 6-tube radio, but I think we can obviously see it's transformerless, which means it's potentially a hot chassis radio. Let's look at the plug here. So the plug, this doesn't look like the right vintage to me. This looks older than the radio itself, although I don't have the cabinet, so I can't be sure. Yeah, so the plastic housing has come loose on this. This has reached the end of its life here. These things are all loose. But it's been done correctly. Can you see that the wires come up, come up through the middle, and then it's been brought around the prong to reach the screw. Well, that's the proper way to do these. So safe to use? Yeah, I think so. And what about the cord itself? So the cord also doesn't really seem right. This might be the original cord. Feels a little like rubber. And it looks fine. Great, we should be able to plug it in. It's got a little tiny light bulb up here. Doesn't quite look right. Very clean. I will thank the owner, he's the one who cleaned it up. Not much else to see up here. The antenna. So it's kind of a busy antenna here. 1, 2, 4 terminals. In every case, the wires brought out to this side and soldered on. That's a little unusual. Usually that's done on the back side. Three wires. 3 wires coming to the antenna. One right here. So I think your standard loop sort of antenna. We'll know when we get to the schematic once that comes along. No reason why I can't turn this up on its side. Let's take a look underneath. Ooh. So I'm not the first one to look under here. Look at that thing. Leaping right out at me. This is beautifully sealed up here. This has to be new. Well, it doesn't have to be new, but so the bracket is screwed in, it's not soldered in. Well, it might be original. 33 microfarads blue, 33 something else, and 47 red. Okay, so I can see the black wire from the capacitors right onto the chassis here. Oh, wait a minute, that's not the black, is it? Yeah, the black wire from the capacitor right on the chassis. I'll look for some other chassis connections here. I see the frame of the tube socket here is soldered right to the chassis. So on terms of the tuning capacitor, right, which is right here, it's mounted up on rubber grommets, and they look to be in good shape. So that's sending a message about the frame of the capacitor is not at chassis potential. And I have experienced quite a big shock years ago from this kind of situation, so I tend to look for it. So I find it with my eyes and not with my fingers. I don't know necessarily that that's a shock hazard, but something worth noting. So now just looking generally at the components in here, kind of a wide range, that guy. So I see a yellow capacitor here and a yellow one up here. Those are replacements done more recently. That's what would make me think this is a replacement too. And here's what looks like, is this the output tube up here? I'm pretty sure that would be the output tube. 35L6. And it's got this capacitor on it here. Almost certainly that's the cathode capacitor, but that should be in here too. Blue, red. It's red. Can I turn this? Not really. Red is 47 at 160. They're all at 160. All three of them are at 160. 33, 33, and 47. So this one comes over here to the output tube. What I'm thinking here is usually the bypass capacitor for the output tube is contained in here. It's one of the ones in here. But maybe not. Maybe not in this case. So, but I'm pretty sure that would be a replacement. You know what? I couldn't even be sure of that, really. Something we need to look at, though, because we need the bypass capacitor to be in good shape. Just looking over resistors, looking for anything that looks like it's been hot. Let's see, this choke wires are coming through a hole behind the capacitor here. So I'm looking for resistors in this area. A high wattage resistor. I don't really see one. What's this? Looks like a capacitor. I don't see any high wattage resistors. So we've got 6 tubes in here. We already know this is a 35 L. This is a 35L6. This is a looks like 35 Z5. It's very hard to see. So 35 and 35, that's 70 volts. 70 from 120 leaves 50 volts. These are all 12 volt tubes. 4 times 12, 48. 48 is 50. So there we are. So there's full line voltage dropping across all these tubes. There's no dropping resistor or anything like that going on. Now, how's the light bulb fed? The light bulb is probably fed. The light bulb wires going up this way, probably fed from a tap on the rectifier heater. That's probably how it's fed. Because in these radios there's no easy way to get light bulb voltage and current. There's no transformer, there's no 6.3 volt heater circuit. So they sneak it out of the rectifier heater by putting a tap on the heater. That's why a lot of these lights behave weird when you first turn the radio on. They come on really bright and then they get dull and then they come up again a little bit. Because of what's happening with the current flowing through the rectifier here. Well, there's no reason why I shouldn't plug this guy in, except what's this wire sticking out here? So why is there a wire sticking right out like this? So this wire's coming around and soldered to this terminal. Yeah, that's all it's doing. So we can take a wild guess that this is where you would hook up, an extended wire or something like that. That would be my wild guess on that. Let's just curl it up here so I don't get poked in the eye. Yeah, let's give it a go. It's got its own antenna. Should work right off the bat. Now, let's see, on off. Is that volume? Probably not volume. Hard to say. No. You know what? I think this is volume. 1, 2. Yeah, that's volume. Okay. I'm judging by the number of wires coming to the potentiometer. There's only 2 coming here. Probably tone control. 3 coming here. Volume control. Okay, so volume down. Switch on. I'll plug it in my supply. Now this is the first time you've watched this lousy plug. This is the first time you've watched my videos by some chance. This is the first one. I'm starting on a radio here and you might have never watched one. By now you realize you're watching me do this essentially live, even though it's being video recorded. I really don't know what's going to happen next. That's the way this works the whole time. The whole time. So here along for my ride. Okay, so it's on but volume down. So I'm going to apply power to this, but it's coming here through an isolation transformer, a fairly large transformer. It's this thing right here. And that isolates away the power here on my bench from the general electric system. And by doing that, that means there is no relationship between this thing and the earth. In other words, I could take a voltmeter, and no. I could take a really lousy voltmeter, an old low impedance voltmeter, stick it on the chassis here and stick it in the ground. It doesn't mean anything because there's no relationship, because I've isolated this away. So that keeps me from getting the kind of shock you could get from a radio just like this by putting your hand on the chassis and sticking your foot on the basement floor, which I will not demonstrate under any circumstances at all, ever, never, except by accident, which I hope to never do. I shouldn't get a shock in the shop here. The fact is, I would probably feel a little bit of a tingle. It wouldn't be 100% shock free, but I wouldn't get killed anyway. And that's what I'm doing for my safety here. Now the other thing that's going on is I'm using a dim bulb light system. System's a strong word for this, which prevents a short circuit current from flowing into the radio I'm working on. So you see these 2 old incandescent light bulbs I have here. Isn't that something, eh? Old incandescent lights. With my little switch panel up here, which should be off, I can direct the power through the light bulbs to the project. The more current drawn by the project, the brighter the lights get. Or I can bypass the lights and just send straight from my transformer straight to the project. So we're going to start up with using the lights here. So that energizes the system, so to speak. That's a main power switch, and this is a selector. Down means through the lights, up means straight through, no lights. Now what happens is, if there's a big short in here for some reason, there's something stupid, maybe even a short right in the plug here that I didn't spot. When I turn the power on, all that will happen is the light, 1 or 2 of them here, will come on full tilt, and I'll certainly know something has gone wrong. And the idea here is to protect mostly a transformer, but there's no transformer here to protect, but mostly to protect things and to not rely on my house circuit breaker to save me if there's something wrong here. That's a bit of a long shot. Okay, it's a long explanation. I want to read more about what I'm doing with these lights. Just get on the internet and look for dim bulb electrical safety or something like that, and you'll be able to read up more about what I'm doing here, because it's no secret. Okay, again, switches on, volume's down, can hit the power. You watch the light, This light is unscrewed. This one's in. This is a lower wattage bulb. And watch this bulb. If there's some problem, it's going to come on full bright. If everything's okay, it'll come on a little bit, probably, and then dull down, maybe to the point where we can't see it, and then it may show up again. It's hard to say. Depends how much current this guy's going to draw. You ready? So, bright light, turn the power off right away. So very, very dull. You barely see it. Went up, came down. And probably it's going to go up again, but maybe I'm only the one who's going to see it. So I cannot see it. So it's not even enough current flowing into this radio to light this light bulb, which is fine. That also indicates the voltage drop on the light is low because it's not glowing, which means most of the house voltage is reaching the radio here. I got this little box. This is pretty cool. I recommend people getting something like this. This is just a power, like you just plug it in your outlet. A little sound coming out. Plug it in your outlet and it tells you all kinds of interesting things. In this case, you're reading the voltage right at the plug. So it's 110 volts. That's within normal operating range, even though I got a light bulb in the circuit. So there's a couple of volts disappearing on that light bulb probably. If I flip it straight to the outlet, this will probably go to 118 or something like that. So that's fine. Everything's great. Good. The radio's actually essentially fully powered. You can see the little light has come on, but it's not very bright. I'm not sure what good that would do you unless you're in a totally dark room. Now we're hearing something which is really good. Let's turn it up a little bit. Oh, so we got loads of volume. That's another really good sign. Okay, and another good sign was the owner of this radio told me it works. So let's tune. It's definitely tuning. Thought I heard a voice there. There's one. Now it's pretty tough in my shop to pick up a good, clear AM radio signal because of all the stuff that's in our homes these days. That's a little better. So what's happening here is the loop antenna is directional, and if I turn it in a certain direction, it will bring in the signal the strongest, of course. But really what you can do with these directional antennas is reduce the noise in a situation like this. I turn it up a little bit. I just get rid of the noise. So the radio signal didn't get much louder. The noise just kind of disappeared. Well, that's really unusual. So I'm rotating the radio through 180 degrees. I expect to get the same reception either way. Tune the radio a little bit here. So it sounds terribly distorted to me. I think they said 640. Let's try another one. Station there. Something a little odd about this, because again I rotated the radio through 180 degrees. Expect to hear the same thing this way or that. That's pretty similar. Of course, going to be some sound change because the speaker is aimed in a different direction. Sounds pretty similar. I don't know. Okay, bottom line. Radio appears to work. Sounds a little distorted. Probably the next thing that would be fun doing is doing a voltage check through the radio and just see what kind of voltages are on the tubes. See if we can spot anything right off the bat that way before I start making changes to it. I think we can just keep everything rolling here. Now, this is a hot chassis type radio, but it's not plugged into a regular outlet. If it were, I would get out my voltmeter and I would read from the chassis to something grounded. And I'd look for 120 volts or 0. Or 60, 50, 60, 70 volts, something in the middle. Those are two totally different cases. This guy, if I read him with my voltmeter, it'll probably say there's 60 volts on it. We'll give it a try in a second. But hooking up the ground is a nerve-wracking thing to me. Now the fact is, I'm in an isolation transformer. There should be no problem. This might make some noise. So now the sound quality has changed because now I've introduced the standard or hydro ground, if you like, through this wire. So this is no longer isolated in any way. Once I hook this up, this is now an unisolated machine. Before I could not get shocks to ground from it very well. Now I can. So if I take I'm dwelling on this because these radios are dangerous. And that's why I'm dwelling on this, and I don't know who you are. Okay. And before I get going and don't say anything, I want to say a few things about it. So. But if I were to take my slipper off, stick my foot on my floor, I'm in the basement of my house, so it's basically concrete, and then touch the chassis, I could get quite a shock. Okay, I'm dwelling on that and I'm babbling. Stop. That's another thing that happens here is, I'm all alone in my shop here, even though you're watching. You're not actually here with me. I can go wild. Great, so we're ready to make some voltage measurements here. So I put the meter on 150 volts full scale. Give you a chance to see it. First thing we'll do is we'll look at the B plus voltage by looking at the wires coming out of this big capacitor and see what we got. So here's a blue one coming right here. So that's 80 volts. There's another one. That's almost 100 volts. There's another one. That's about 80 volts. So we'll probably find the 100 volts on the output tube. The output tube, I just want to look to be sure. Output tube is this guy with what I believe is this capacitor, and this is almost certainly the plate right here, and we should see that's the 80 volts. I kind of thought we might see the 100 here. Let's go here. Okay, nothing, something. Okay, so this is the negative side of this capacitor. It's going to ground. The positive side is coming over here, and we're getting a little positive voltage on it. So we gotta look into that a little bit. Let's keep going around. There's a negative voltage here, very small negative voltage there. Nothing there. And we got a very small. Oh, son of a gun! What just happened? This is what just happened. Scared the bejesus out of me, cat. No! Don't be sniffing at it. Don't be sniffing at it. Not while it's on. You can be up here, but Don't be playing with my radio. So that's the small voltage is kind of suggestive of a leaky capacitor. Yeah, I wanted to look at the pinout on the 35L6. Shadow, you going to help me today? Last couple of days have been strangely warm here again. 6-8 degrees outside. 35L6 beam power tube. Mounted in a position. Maybe supplied with pin 1 omitted. Heater. So the current in all the heaters is going to be 150 milliamps. Here. And just zooming through it here. What about plate supply voltage? 110 or 200. So yeah, it's right in the 110 area. Fixed bias. We're on cathode bias. Cathode bias resistor should be their suggestion 180 ohms. Just keep that in mind. And what we're looking for is the what is what on here. So grid 8 is showing a bit of a positive voltage. If it's the cathode, it's fine. So just a little tiny positive voltage there. 8 cathode. So the cathode's being pushed positive by the cathode resistor, which is in there somewhere, I'm sure. Could be this. That's too big. Can't be that. So I don't see the proper size resistor in there. So, that's curious. Well, this may be, I don't know. That's what you say when you don't have the schematic. 35L6. So the other one, so the grid is 5, and the grid should probably show basically 0. The grid is 5. 1, 2, 3, 4. This is 5 here. You can hear it. A tiny positive voltage there. How tiny? Okay, so 5 volt scale on my meter now. So it's a 4 volts. 4 volts positive to the chassis. So we really wouldn't want to know the voltage relative to the cathode. The cathode measures, I'm going to guess that's like, well, 3 or 4 volts difference, I'd say. So that makes the grid 4 volts negative. What kind of grid bias are we looking for here? Sometimes it won't say in these things. Under fixed bias, minus 7 volts. So over to minus 3, 4. I don't know, it's all kind of curious. I don't expect to find little positive voltages there. So indeterminate, but you can see this old capacitor right on the terminal, I'm finding a little bit positive. If we look at the other side of this capacitor, the spot where it goes. There it is, right to there. Okay. I think we'll find full B plus there. So, right here. And there you can see on the meter, I've changed the scale now. That's not full B plus, that's 45 volts here. And on the other side of this capacitor is a little bit of positivity remaining. So I think that's leaky, and I think it's pushing the grid up. The grid being more positive than it should be, or less negative than it should be, means the current, quiescent tube current is a little high. So the tube's running unnecessarily hard. You wear out the output tube early if you play this radio every day for 6 hours for the next 2 years. And now, let's see. We saw a very low voltage on here, on this tube. These are just the general signal tubes. Let's just poke around and see what we get. So that's going ever so slightly negative. This is, you can hear it. It has a capacitor from the volume control. It has a fairly large, looks like a 1 meg resistor to ground right off it. This is the grid of this tube. This would be the preamp. This is probably the detector and preamp for the output tube. The detector for the radio, preamp for the output tube. So we're seeing negative there. That's good. Somewhere we already did see a bigger voltage. So that's 40 volts. That's not very much. That's suggesting a bit of a problem here. That wire comes over to this terminal. And this terminal I don't know. Okay. So I'd say it seems like a low B plus voltage here, and that might be the case all through the radio. We'll look at this one. There we are. Now that's the 80. That's what I would kind of expect on each of these tubes. 80 volts, but not on that one. Now this is the detector. Sometimes the detector runs with very low plate voltage, so maybe that's what's going on there. It's the detector and triode. I think it's the detector and triode. Did I miss? So yeah, so there's the 40. No, I didn't miss it. That's it. Done this guy, found him normal. Here's a nice red wire right here. 80. So that's also getting the 80. And we got another tube up here, very hard to access. Yikes. Well, do I see a red wire coming to it? That tube is hanging out of the socket. It's really hanging out. It needs to go in about a 1/4 inch further. Well, I can see a red wire running from this plate terminal, from this tube, running up that way. That's probably carrying the same plate voltage up there. We can guess it's 80 volts on there. So this guy's low, but he's probably low because he's supposed to be low. And we can't really do much more without the schematic. The other thing we can't do is we can't very well align this radio unless it has tick marks. Let's take a look and see. Well, it has no, that's a fault. That's a bubble on the plastic here. Is that supposed to be like that? I don't think so. So I'm looking for some kind of registration mark here which would indicate where the pointer should be when the capacitor is at one extreme. Some grease on it there. I don't see anything. I see holes here and a hole here. Could that be it? That could be it. That could be it. That could be the mark. So let me just turn the tuning all the way one way. Yeah, going way past that mark. All the way the other way. Well past the mark. No, I don't think there's any kind of registration mark here I can work with. So this radio should have a certain kind of tuning feel when you turn this. It should be pretty loose. You should pretty much be able to spin it and let go, and it should. Why am I saying that? Because they took time here, and took time. They went through the problem of putting a big weight. Ooh, what's going on there? Putting a mass on here to give this dial some feeling of weight. But all I feel is the resistance of the mechanism up in here. Like it needs some oiling, I think. So I think if this were the way they intended it, you'd be able to spin the knob on this. That's a big thrill, you know, for radio operation. Spinning the knob, spin the knob. Well, I'm reticent to go forward without a schematic at this point. My cat is really fascinated by this radio. She's just moved right in. I'm just trying to think of what else can we do here that would be of interest. There's just not really much else at this point. I think that might be it. That might be it for today. What do you think, Shadow? Are we done? Shadow, are we done? Do you think we're done? No answer. Never an answer. Okay, well, thanks a lot for watching. And we'll get better information on the radio. Tomorrow we'll do some component replacement and start tuning it up. See what we get.